This is Chemistry for Grade 9, produced by Tigray Education Bureau, transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media, and also FM Maqala 104.4.
Hello students, this is Chemistry for Grade 9, presented by Guish Tasfai. Welcome to the 4th week lesson, that is Unit 5, Physical State of Matter. 5.1, Introduction, and 5.2, Kinetic Theory of Matter and Properties of Matter. Students, do you remember the last week lesson? Might be, I suppose. In our last week lesson, you learned about factors affecting the position of chemical equilibrium, such as temperature, pressure, and concentration. Let's begin our today's lesson now. Please open your textbook at page 165. Students, by the end of this lesson, you will be able to name the 3 physical states of matter, state the kinetic theory of matter, explain the properties of the 3 physical states of matter in terms of kinetic theory, and compare and contrast the 3 physical states of matter. 5.1 Introduction. Every material around our environment is matter. Matter is anything that has mass and occupies space. All materials, at least in principle, can exist in 3 states. These are solid, liquid, and gases. Students, what happens when you heat an ice cup? Good. When an ice is heated, it melts to a liquid, and further heating evaporates it to a gas. Since the physical state of a given sample of matter depends on temperature and pressure, changing these variables may change the behavior of the substance. Therefore, those 3 states of matter are interconvertible. Students, describe the properties of solid, liquid, and gaseous states of matter. That is nice. Solids are rigid objects with definite shapes and volume, whereas liquids are less rigid than solids and are fluid. They are able to flow and assume the shape of their containers. And gases are fluids, but unlike liquids, they can expand indefinitely. Take notes. In addition to the 3 states of matter, there is also a 4th state of matter called the plasma state. This state of matter exists at extremely high temperature, and no materials exist in the plasma state. 5.2 Kinetic Theory of Matter and Properties of Matter. 5.2.1 Kinetic Theory of Matter. Students, explain in which state do the particles possess the highest kinetic energy. In a way, perhaps, in a gaseous state, the molecules possess the highest kinetic energy. since the motion of particles of gases is higher as compared to those of liquids and solids. Therefore, the kinetic theory of matter gives an explanation of the nature of the motion and the heat energy based on the following three assumptions. 1. All matter is composed of particles which are in constant motion. 2. The particles possess kinetic energy and potential energy. 3. The difference between the three states of matter is due to their energy contents and the motion of the particles. 5.2.2 Properties of matter. Students, compare and contrast the density of solid, liquid, and gaseous forms of a substance. Sort of, yes. The density of a substance in the gaseous state is lower compared to the density of the same substance. In the liquid or solid state, that is because the properties are much farther apart in a gaseous state. At normal atmospheric pressure, most liquid substances are denser than gases. The higher the density of solids results from the fact that the particles of a solid are more closely packed together than those of a liquid or a gas. Now let us explain the properties of gas, liquid, and solid in terms of kinetic theory one by one. Properties of gases. Gases have neither definite shape nor definite volume. Gases are highly compressible. Gases have lower boiling point than liquids and solids. Gases have low density compared with liquids and solids. Gases exert pressure in all directions. Gases diffuse and flow spontaneously into each other. Gases exist at high temperature and low pressure. Their kinetic energy is much greater than the attraction force between particles. Properties of liquids. Liquids have definite volume but have no definite shape. Liquids are slightly compressible. Liquids are fluids. Liquids have lower boiling point than solids. Liquids have higher densities than gases. Their particles have more restricted motion than gases. Liquids exist at intermediate temperature and pressure. Their kinetic energy is almost equal to the attraction force between particles. Properties of solids. Solids have a definite volume and shape. Solids are incompressible. That is because the particles are very close each other. Solids have higher boiling and melting points than liquids and gases. Solids generally have higher densities than gases and liquids. Solids are not fluid and do not diffuse. Solids exist at low temperature and high pressure. Their kinetic energy is much less than the attraction force between particles. Students, let me ask you some questions. You try it. Question number 1. Discuss the compressibility of solid, liquid, and gaseous forms of water. discuss the compressibility of solid, liquid, and gaseous forms of water. Answer. During compression, gas particles that are initially very far apart are brought close together. Hence, the volume of a given sample of a gas can be highly decreased, whereas liquids are much less compressible than gases. That is because liquid particles are more closely packed together, and solids can be considered incompressible. Question number 2. Explain the motion, distance, and attractions between the solid, liquid, and gas. Answer. In solid particles, the motion of molecules is low, and the attraction between molecules is high. That is because the distance between molecules is very close to each other. Whereas in liquid particles, the motion and the attraction between molecules is medium, because the distance between molecules is relatively close to each other. But in gaseous particles, the motion of molecule is high, and the attraction between molecules is low. That is because the distance between molecules is very far apart. Question number 3. How does the kinetic energy of particles vary as a function of temperature? How does the kinetic energy of particles vary as a function of temperature? Answer. The kinetic energy and temperature of a gas are directly related. Temperature is a measure of the average kinetic energy of the particles in a sample of matter. Since at a given temperature, all gases have the same average kinetic energy. The last question is question number 4. Use the kinetic molecular theory to explain why both gases and liquids are fluids. Use the kinetic molecular theory to explain why both gases and liquids are fluids. Answer. This is because both liquid and gases can easily flow. Students, now let us sum up the main points of our lesson. Matter is anything that has mass and occupies space. Matter exists in the form of solid, liquid, or gases. The kinetic theory of matter gives an explanation of the nature of the motion and the heat energy. Solids have a definite volume and a definite shape, whereas a liquid has no definite shape. It takes the shape of its container. A gas has neither a definite volume nor a definite shape. Gases and liquids are fluids, whereas solids are not. Fluidity is the tendency to flow. Students, that is all for today. Next week, you will learn about 5.3, the gaseous state. Until then, goodbye.